Okay, beautiful. Here we go. We're going to do some, I think this is pretty easy. There's a lot of terminology in this lesson, but once you get the terminology under control, this is not that difficult in my humble opinion, but we'll see. Maybe you have a counterpoint. So we're going to start with two ways. Let me try that again. 3 ways that 2 lines can interact. Okay? In other words, I'm going to draw 2 lines. How can they interact with each other? Ideas. Draw 2 lines on your iPad. What are they going to do? Go ahead, draw 2 lines. Good. What can you tell me about those 2 lines? Meaning? Good. Erase that. If you guys could see her iPad, you would be amazed. Draw 2 more lines. What about those lines? Okay, good. Which means? Okay, good. Erase those 2. Draw 2 more lines. Excellent. What can you tell me about those lines? They just cross. Fancy term for crossing is? Intersect, which means? They're intersecting, right. Okay, what's a dog? A dog's a dog. Gotcha. Okay. Go back to the perpendicular. Isn't perpendicular just a fancy way of intersecting? Yeah. Okay, so like perpendicular is a subset. That's a fancy term. It's a subset of intersection. So they could intersect, right? Have 1 point in common. Is it possible for 2 lines to intersect and have more than 1 point in common? No. They're parallel. Ooh, new symbol. Parallel. 2 little parallel segments next to each other. Train tracks. They do not intersect. You knew this already, right? What you didn't know was the 3rd way. And the 3rd way is a little bizarre because it's not something we commonly deal with. So before I show you the 3rd one, notice that everything that you're doing right now is on a flat surface. You're writing on your iPad or your piece of paper or wherever it is you're taking notes. Okay, you're working in a 2-dimensional world. Most of this class happens in a 2-dimensional world. However, in 2nd semester, we'll get into 3 dimensions. And when we get into 3 dimensions, you can have something called skew lines. Now, what do skew lines look like? This is a visual. Look at me, please. Skew lines are like this. Okay, they don't intersect. They're not parallel. And they're in different planes. Okay, you can't really draw that on a 2-dimensional surface because it's a 3-dimensional thing. We won't deal with skew lines that much until 2nd semester. I mean, obviously, we've defined it. I'll ask you some questions about it, et cetera, et cetera, et cetera. Okay, we good? Oh, there's a picture of some skew lines. Okay. All right, so here's the picture. I've got a plane. It's blue. And 3 lines. Evan, tell me what you see in that picture, other than a blue plane with 3 lines. What else do you notice?
E, G, and then K, H are parallel.
Beautiful. And notice that extra little set of arrowheads, these little red guys over there. That's how we show that lines are parallel. We may have talked about that in the past, but you put an extra set of arrowheads on it, and that means that they are, in fact, parallel. Okay, what else you got for me, Evan? What else you notice?
Is it K, H, and F, J are skew?
Very good. Lines K, H, and F, J are skew. They don't intersect, but they're not on that same blue plane. Good. Anything else?
Would it be the same thing for E, G, and F?
No, they actually intersect. Notice they intersect at the point G.
Oh, then E, G, and F, J are perpendicular.
They appear to be perpendicular. Right, so we have all 3 scenarios outlined there. We've got the 2 parallel lines, we've got the 2 intersecting lines, and we've got the 2 skew lines. Okay, good. All right, so now, new term, Another new term, transversal. A transversal is a line that intersects two other lines. And when it intersects the two other lines, it's always, without exception, going to form 8 different angles. So we're going further down the rabbit hole of angle pairs. We've already talked about some angle pairs. What are they, Ava? What angle pairs did we already talk about? Adjacent. Supplementary. Complementary.
Congruent.
No, not necessarily a pair. You want some help?
Yeah.
What do you got?
Vertical.
Vertical and one more. Say again? No. Anybody else? 5th pair? Linear pair. Okay. Linear pair, adjacent and supplementary. Supplementary add up to 180, complementary add up to 90. Vertical across from each other, equal, adjacent next to each other. Okay. Now we're going to get a whole bunch of other pairs. So if you look at that picture that I have up there, we're going to pick an angle from the first point of intersection. Okay, so since, stop it. What the heck? So since that's one point of intersection, and that's another point of intersection, in order to get pairs of angles, we're going to pick one angle around 1 through 4, and we're going to pair it with an angle around the other point of intersection, 5 through 8. Okay, now, don't go and memorize these ideas based on the angle numbers that I have labeled in that particular picture, because that's going to change. Understand where the angle pairs come from, not based on the numbers that I use for explaining. Okay, so questions? We're good? All right, transversal intersects two of the parallel lines, forms a whole bunch of angles. Here's the first one. Corresponding angles. Corresponding angles are in the same location. So, for instance, that mooing cow is in the upper left-hand corner around that first point of intersection. Okay, by point of intersection, I mean this guy right here. So its corresponding angle is the other angle around the other point of intersection in the upper left-hand corner. Okay. Bob, where are the other pairs of corresponding angles?
2 and 6. 3
Good.
3, 7, 4.
Good.
4 and 8.
4 and 8. Awesome. 4 pairs of corresponding angles. Upper left, lower right, upper right, lower left, lower left. Well done. Okay, now in case you have trouble with the math, we're up to 6 pairs now. Am I going too fast or are we okay? So again, in your notes, don't rely on the fact that it's angles 1 and 5, because that's going to change the problems. Understand that it's upper left, upper left. Next type, alternate interior angles. Okay, so the name of the angle can help you figure out which angles you're talking about. Alternate, meaning it's on opposite sides of the transversal. Interior, meaning it's on the inside. I got a juice. So here's the interior. It's the space between the lines. Alternate, meaning it's on opposite sides of the transversal. So that star wearing a top hat is on the left side, the other one is on the right side, and they're in the inside. Bella, where's the other pair of alternate interior angles?
7 and 2.
Nope, those are on the outside. We have to be on the inside.
5 and 4.
5 and 4, beautiful. Okay, good. Only 2 pairs of AIA. If we have an alternate interior angle, what would be next? Alternate exterior angles. The creepy unicorns. Opposite sides of the transversal on the outside. Karen, what's the other pair of alternate exterior angles?
7 and 2.
Beautiful, 7 and 2. Gesundheit. By the way, if you could zoom in on that little unicorn, it's so creepy how it turns and looks at you. It's just, it's like it's gazing into your soul. Just thought I'd share.
It doesn't move on the window.
I know. That's just a PDF you're looking at. If I shared the actual slideshow with you, it would move and look at you. Okay, here we go. Everybody good? We're all caught up? Any questions so far? All right, beautiful. Same side interior angles. Again, let's break the name down. Same side, meaning on the same side of the transversal. Interior on the inside. So those two swimming fishies would be one pair of SSIA. Abby, where's the other pair?
4 and 6.
Outstanding. Whoops. If we have same side interior angles, Meg, what's next? Hot diggity. Walking crocodiles. And Meg, while you're at it, where's the other pair of same side exterior angles?
2 and 8.
Sorry? 2 and 8, beautiful. That abbreviation is wrong. It should say SSEA. I don't know where that C came from. I apologize. How many is that? 5? Corresponding alternate interior, alternate exterior, same side interior, same side exterior. So we're up to 10 pairs of angles. Ready?
So
Is not a good way to start a question. Start over.
the
Oh, you just move it to the second word? Try again.
the crocodile is like on the left side, but I don't. Would it be 1 and 5 are the other same side exterior angles, or would that not work?
No, 2 and 8.
So it's gonna
Because you got to be on the same side, and you got to be on the outside of the.
So, but like this had the crocodiles on, that's also like which side is considered the outside? Both.
The stuff not between the other two lines.
Yeah. So the crocodile side's also an outside.
Yes.
Okay.
Yeah, these are same side exterior angles also.
Okay.
And then the other pair, like Meg said, is 2 and 8. Okay. So, notice I changed the numbers. That I turned the numbers into letters. Mouse jaw. Olivia, where are the corresponding angles, please?
Which one?
For that picture. There's one behind you if you can't see it. I'll give you a hint. They're in the same corresponding location. No, pairs. I just need 2. No. Back up.
M and E,
M and E is 1. Upper left, upper left. Keep going.
O and J.
Has nothing to do with the killer.
S,
Anybody? Is that 2? Is that? That's probably before you guys were born, right? You do know who OJ is, right?
Yeah.
Yeah.
Okay.
We just
Go ahead, back to you.
S and W,
Good.
U and A.
Good. Okay, so again, remember with these pairs, you're picking one from around the first point of intersection and pairing it with one from the other pair or other point of intersection. Okay, Olivia, you got that? Good, so then try this one. Give me a pair of alternate interior angles, Olivia. No. You got to pick one from the top point of intersection, so let's start with S. Now pick one from the bottom point of intersection. Which point from E, J, A, or W is the alternate interior angle to S, as in salamander? It is J. Good. Now give me the other pair. Perfect. Okay. Good. Who have we heard from? So yeah, how about the alternate exterior angles, please?
M and A,
Good. And?
O and W.
Good. Same side interior angles. Amelia.
U and J.
Wait, I forgot what we're doing. Yes, U and J and S and E. Well done. And last but not least, same side exterior angles, Brody. Don't look at me in that tone of voice.
E and H. Or I know, I was looking at mine. O and A.
O and A, and the other one is?
N and W.
Well done. Okay. So now I changed the picture a little bit. How is that picture different than that picture? What do you notice? That picture, that picture. Bushy.
One of them has the angle measures.
Okay, what else? That picture, that picture, that picture, that picture.
The lines are parallel.
Bingo. Now I made the lines parallel. What do you notice?
There's an angle 65 degrees.
Good. Anything else?
You can solve it now.
You can. How big is angle 6?
65 degrees.
Why, Karen?
Because they are vertical.
Good. Good. Yes, they are vertical. Okay. Well done. How big is angle 5? Karen?
100 and
Don't be bashful while busting out your calculators, by the way. You're going to need them at some point.
115.
115. Why?
Because they equal 180 together. They are complementary. No, supplementary.
Supplementary. Also a linear pair. Okay. How big is angle 7? Karen?
Oh, 115.
Could you give me 2 reasons why angle 7 is 115 degrees?
Because 6 and 7 are also supplementary, and 5 and 7 are vertical.
Good. Okay, now notice those 3 answers have nothing to do with the lesson today. This is stuff we did on day 1 or day 3, whatever it was, or last chapter. I forget. Okay, now things get interesting. Karen, how big are angles? Well, how big are one of the angles? 1, 2, 3, or 4? Which one would you like?
1.
1. How big is angle 1?
115 degrees.
Okay. Why?
Because lines are parallel.
Does everybody agree that angle 1 is 115? Okay, we'll discuss why in a second. Now finish. How big are angles 2, 3, and 4?
2 is 65 degrees, 3 is 65 degrees, 4 is
Notice, when the lines are parallel, there's only 2 different angle measures. That's it. An angle is either going to be 65 degrees or it's going to be 115. No other options. You can also incorporate the idea of acute angles and obtuse angles. All the acute angles in that picture are 65. All the obtuse angles are 115. Now, where things got a little shaky is Karen trying to explain why angle 1 was 115 based on the other 4 angles down at the bottom, and that's where we're going to go next. Okay, I've got a bunch of very simple theorems for you that explain how that happens, okay, which will allow you to figure out any one of those angle measures given the lines being parallel. Okay, so here's the first one. Corresponding angles are always congruent when you have a transversal intersecting 2 parallel lines. This is based on the idea that the lines are parallel. If they're parallel and cut by a transversal, then all the corresponding angles are going to be congruent. Okay, now, how do you know that? Well, we just did it right there. If you look at each of the corresponding angles, angles 1 and 5 are corresponding. They're both 115. 2 and that 65 are corresponding. 4 and 7, 3 and 6. They're all the same values. Okay. So you could have said, when I asked you why is angle 1 115, you could have said because it's corresponding to angle 5. Done. Okay, one possibility. Next theorem. The alternate interior angles are also congruent. Again, if the lines are parallel, then the alternate interior angles are congruent. If we go back to our picture here, okay, angle 5 and angle 4 are congruent. Angle 3 and the 65 are congruent. Okay, so Kieran, why is angle 4 115? Because it's an alternate interior angle to angle 5. Why is angle 3 65? Because it's an alternate interior angle to the 65-degree angle. Now, before I go back to the other slides, what can you tell me about alternate exterior angles? Second good? Good. What about those measures? Anybody? What's the relationship between the alternate exterior angles? Oh, you have your hand up? Are you changing your mind?
No, aren't they the same?
They are not. Notice angles 2 and 7 are alternate exterior angles and they don't have the same
They're
measure.
not same size?
What did I say?
Alternate exterior.
Let's back up. I'm on the wrong angle measure. You're 100% correct, Bob. Nice job. They are the same. Angle 1 and angle 7. For some reason, my brain processed same side. Glad you guys are here. I would be totally confused. Okay, which gets us to this now. Okay. Nope. Where is it? Where's my alternate exterior? Ah, there it is. I knew we'd get there eventually. So I wanted to do all the congruent ones first. Corresponding, alternate interior, alternate exterior are all congruent. Now if we go back, let me try that again. What is the relationship between the same side interior angles? Angles 3 and 5, for instance. Go.
They're at 180.
Also known as? What meal do you eat after lunch? What's that?
Supplementary.
They're supplementary. Right. You have supper. Does anybody call it supper?
My grandma.
Oh, wow. Did you just make an old joke about me? You might not do so well on the quiz. Just saying. They are supplementary, yes. So now we're here. Same side interior angles are supplementary, and the same side exterior angles are supplementary. Okay, so that's the first component of the slideshow today, and that is understanding the terminology and how the angles relate to each other. Any questions so far before we get into some algebra? Okay, good. So what we're going to do then, this is a real easy problem. I don't think that's a challenge for anybody. If I gave you one angle in that picture, you could all find the other 7 angles. Is that a safe assumption? Yes. Okay, so that's not even challenging. So let's make it more interesting. What can we do to make it more challenging? Well, what we can do is create some algebra problems. So hold on, let me skip this. I'll come back to that in a second. We're going to do a problem like this. I'm going to take that same picture of two parallel lines cut by a transversal and throw some algebra in there. Okay, now to do that, I have some hints for you. Number one, figure out what kind of angles you're talking about. Which of the 10 pairs of angles are we looking at? Number two, decide if those angles are equal or supplementary. There is no other option. You pick any two angles in the picture, they're either going to be supplementary or they're going to be equal. If they're equal, set them equal to each other. If they're supplementary, add them up and set them equal to 180. Step 3, do some algebra. Okay. In other words, solve for x, solve for q, solve for whatever the variable is. And then number 4, plug it back in and find some angle measures. Okay? We good? All right, so let's do this. There we go. Now, the two angles we know something about are here and here. And I know I turned the picture sideways just to make things more interesting. Which of the 10 angle pairs are those two circled angles? We know they're not adjacent, they're not supplementary. Well, they might be supplementary. Say again? Same side exterior, outstanding. What do we know about same side exterior angles? Are they congruent or supplementary? Supplementary. Now, let's suppose you take a blow to the head after class and you forget all of that. Look at the picture. This, aside from telling you the value, is clearly an obtuse angle. This is clearly an acute angle. They can't be equal to each other. An obtuse angle can't equal an acute angle. So they're supplementary. What do I do with those two measures? See here.
You add them something equals
Solve, please. Don't be bashful. Shout out your answers. Any time now.
x equals 20.
20, confirmation? We agree, 20. Okay, so I figured out what pairs they are. I figured out the relationship. I set up an equation, I solve for x. The last part is plug and chug and answer the question. Notice, what is the value of x? And how big is angle 4? That's why that guy is there. How am I going to find the measure of angle 4? Question.
You just use 125 degrees.
Okay, that's one way. Good. What else? Who's?
You could add, you could do 125, sorry, 180 minus 2x plus 15.
Good. Yep, because these are an adjacent pair. You could take that 20, plug it in here. 2 times 20 is 40, plus 15 is 55 degrees. If that's 55, then like Lucy said, 180 minus 55 gives you that 125. A couple different ways to find that angle measure. And now we can find any one of the other 8 angle measures. They're all going to be 55 or 125. Does that seem difficult? No. Okay, good. It shouldn't. Especially if you remember to use those 4 steps. Things will get a little bit more complicated. As long as you keep coming back to those 4 steps, you should be fine. Shall we try another? We shall. Okay, this time I'd like you to solve for x and for y. Sorry. Let's ignore this. And just find x and y. Okay, stop what you're doing for a second. Notice, I want to try to match up the x's. So I've got an x here and an x here. I could match up the x's and the y's, but that's going to cause a whole bunch of problems because I can't solve that equation. This is not one of the pairs we've talked about. They're not alternate interior, they're not alternate exterior, they're just one of the weird pairs that we didn't talk about. But, how big is that angle?
3x.
3x. Does everybody see why that's 3x? Okay, now I walked around and almost everybody had this equation. Which is perfectly correct. Now, why did you have that equation? Did you realize that this angle was 3x and therefore they're supplementary because they're a linear pair? Or did you realize, well, the 3x is the acute angle, the 9x plus 12 is the obtuse angle, those two have to add up to 180. I'm adding them up and setting them equal to 180. Doesn't matter. You're still going to get the same value. What's x?
14.
14. Okay. Now what? How do I find y?
You set 9x plus 12 equal to 4x minus 10, but you plug x in.
Okay. Take this x. You saying plug it in there?
Yeah.
Do I have to plug it in there?
No, you can also put it into 3x.
Could plug it in there. 3 times 14 is 42? 42, 42, and therefore this angle is 138. Or 180 minus 42 is equal to 4y minus 10. Any one of those will get you a value of y to be 37. Thank you. Problems? Wow.
Also 9 plus 12, but put x in, why is it 9x plus 2?
Because 9 times 14 is 138. Oh, I see what you're saying. Yeah, I made a mistake. Sorry. Is that better? Okay, good. I'm off my game today. Problems? Questions? Do you think I got one more for you, maybe? Oh, yeah, I do. Crook problem. All right, these pop up every once in a while. And in order to solve the problem, what we're going to do is draw in an extra line, which is called an auxiliary line. So it's called a crook problem. You probably never heard that term before, but a crook, like this thing right here, is called the crook of your elbow. Okay, it's also the most incredibly painful spot to get tattooed in your life. Right there, almost passed out. It's horrible. Don't do it, kids. Okay. So we want to find the measure of angle 1, and what we're going to do is we're going to split that crook angle into 2 parts by drawing a line through here. All 3 of these lines are parallel. Now, let me say this first. That red line does not split angle 1 in half. Okay, it splits it into 2 different parts. What you're going to do is find the 2 parts, then add them together to find angle 1. Okay, so for instance, how big is that part of angle 1? Cricket. Nope.
Oh, shoot. I missed that.
Foster.
118.
Nope. It's an acute angle. Can't be 118. Eva.
62.
62. Why, Eva?
Because 62 is like, I think from there. Oh no. The alternate interior.
Perfect. It's an alternate interior angle to the other 62. So when you're when you're doing that, you probably want to cover up that bottom part. Now you can see that that's alternate interior. Okay. Next question. How big is that angle?
Is it 36 degrees?
Say again?
36 degrees?
Why?
Because they're alternating to,
Nope.
or alternate x to,
Nope. What's the relationship between this angle and the 144? Which of the pairs? Cushy.
If you add them together, you get 180.
Which pair are they?
They are same side interior.
Perfect. Same side interior angles. Okay, so therefore, how big is angle 1? Angle 1 is 62 plus 36, which is 98 degrees. Done. So again, draw an auxiliary line through the crook. It splits that crook into two parts. Those parts are not equal. Either work from the top down or work from the bottom up. Find your angle measure. Bob's your uncle. You're good to go. Okay. Questions? All right, we don't see that a lot, but they do pop up every once in a while. In fact, you might see a problem that has multiple crooks. That'll be fun. Okay, we're done. Questions? We're good? Excellent. Let me stop this. Discard.